Okay, so last section we're going to look at for this week is 8.1. Okay, we won't get to finish 8.1 for quite a while because we get the break and then shop week, and then when you come back after that, we'll do part 2. So it'll be a little bit. But overall, I think you'll find this section, compared to the other ones this week, easier. So the goal of this section is to figure out how big the sides and the angles in a triangle are. And we've done that before. When we did it before, the triangle always had a 90-degree angle. This week, it won't. Okay, so the triangle will not have a 90. So when a triangle does not have a 90-degree angle, that's called an oblique triangle. An oblique triangle. And there's really 2 types of oblique triangles you can have. You can have a triangle where all the angles are smaller than 90. An example of that, like a pretty common one, would be equilateral. Think of an equilateral triangle. All the angles are 60. Or you could have an obtuse triangle. That's a triangle where there's exactly one angle bigger than 90. Can you have 2 angles bigger than 90 in a triangle? Why not? Ethan?
Because all the angles have to add up to 180.
Yeah, they'll have to add up to 180. So if you had 2 bigger than 90, it would already add up to more than 180 without the third one. So when we draw a diagram, we have to use one more label that we never had to use before. Does anybody remember the letters that we use to represent the sides of a triangle when we don't know them? Well, Matt, do you remember the letters we use?
We use
What's the most common letters that you use when you're setting up like a formula?
X.
So a lot of times in algebra, yeah, we do use X, but think of there's a certain theorem that you use with triangles.
Oh, A, B, C.
A, B, and C. Okay, so A, B, and C are going to be used for the sides. And we use Greek letters for the angles. That's to avoid confusion. Some books use capital letters for one and lowercase for the other. That gets a little messy. So we're going to stick with English letters for the sides and Greek letters for the angles. A is always across from alpha. B is always across from beta. And C is always across from, anybody know that one? Yep.
Gamma.
Gamma. Very good. Gamma is the new letter we've never had to use because gamma used to always be 90. So we just drew the little box thing that represented a 90-degree angle, and that's all you needed. That's pretty much how I sketch all the triangles in this section. I don't draw any of my pictures to scale. Okay, that's not the point. You don't have to take the time and measure the angle and draw it to scale. All that's important is however you want to draw your triangle, you could flip it and rotate it. Just make sure A is always across from alpha, B from beta, C from gamma. That's what's important. Okay, so there's 2 laws we're going to learn over the next 3 classes. One of them is called the law of sines. That's what we're doing today. And we'll continue next time. And then the other law is the law of cosines. Those 2 laws allow us to solve every type of triangle you could have. The law of sines specifically allows you to solve 3 out of the 5 different types. So there'll be 5 types of problems. Law of sines will do 3 of them. Law of cosines will do the other 2. The 3 types that law of sines can do. First of all, if you're given 2 angles and a side. Law of sines can do that. And you have to pay attention when you're doing law of sines to not only what are you given, but where is it. There's a difference between ASA and SAA. Here's the difference. The first one means you have two angles, and you have a side that is between the two angles. Like the S is physically between the A's, okay, like this. Let's do that side, that angle, and that angle. So you have a side, and that side is the one that's physically between the two angles. It connects the side, connects the angles. Another example would be like this. Angle, side, angle. Again, the side B is the one that's physically between the two angles. Now, side, angle, angle, we're still going to use law of sines to solve it, but the placement of the known side is in a different spot. That would be something like this. Angle, angle, and then anything except B, like A. Now the side is not the one that's between the two angles. It's next to them, it's not between them. Okay, so those are two types that you can use law of sines for. And this other one that you see over here, you might see it written angle, angle, side, that's fine. That means the same thing. And then ASA, well, ASA backwards is the same thing. And the third type that we can do is side, side, angle. And we'll leave that one in that order. We won't write it backwards. It's not nice. Okay, so side, side, angle. So this is where they give you two sides, and they give you an angle. But it's very important that the angle is not between the sides. If the angle was between them, that's SAS. Can't do that today. Okay. So side, side, angle would look like this. Side, side, and then give me any angle except gamma. I can't have the one between. It won't work. So this one, that'll be fine. Or beta. Okay, so those are the three different types of problems that we can solve. So when I ask you, when we start a law of sines problem, and I say, can you classify the triangle for me using 3 letters? I'm looking for you to tell me one of these 3 cases. Any questions on that? All right, so these 3 cases, and only these 3, is what we use the law of sines for. The other 2 cases, I think I kind of hinted at one of them. The other one of them is SAS, not doing that today, and SSS, not doing that one today. So, what is the law of sines? Well, that's what we're going to figure out. So it's a pretty easy formula to figure out where it comes from. So we'll kind of see how it comes about, and then I'm going to show you how to use it. So here is a triangle. I'm going to label 2 of the sides. I don't need to label the 3rd one because I'm not going to use it. So it'll just be less confusing if I leave it blank. Let's label this side A. That angle we'll call alpha. This would be B. And that's B. I'm not going to use side C for this. All right. So the first thing I'm going to do in that diagram is I'm going to create 2 triangles, specifically 2 right triangles, by going just like this. So I just created two right triangles. They're not necessarily the same size. In fact, I think you can see the one on the right is a lot bigger. Okay, but just two right triangles. That line that I just drew in, let's call that H. H for height. Not hypotenuse, but H stands for the height. And what I want to do now, I want to focus on each one of these triangles separate, the left one and the right one. So I'm gonna block the right one. I'm not gonna look at that one right now. And I just want to look at the left one. Okay, what I want to do in that left triangle is come up with a formula for H using the other two things. All right, so now we've done this before. This is right triangle trig. I want to know what trig function I should use. And to figure that out, I need to know the names of H and A from the perspective of beta. So what I'm looking for here is opposite, adjacent, or hypotenuse. What is side H from the perspective of beta? Yep.
Yeah, opposite.
Yeah, that's opposite. And what about side A? Tyler?
Jason?
Well, it's the longest side, right? So yeah, that's the hypotenuse. Out of the three trig functions that we use most often, which one has opposite and hypotenuse in it? Jack? Sine. So we're going to set up a formula with sine. Sine of beta, that's my angle, equals opposite over hypotenuse. That's my opposite. That's my hypotenuse. Now, I want to get H by itself. So then I have a formula to find the height. Abigail, how do I get H by itself?
Multiply sine beta by A.
Yep. Going to multiply both sides by A. That's gone. Times A. And there's your formula for the sine, for the height. A sine beta. Okay, just to give that box a name, I'm just going to call that box 1. Okay, we'll look at box 1 again in a second, but for now, we're done with it. Questions on how we got that formula? So nothing really fancy, just right triangle, we've done that before. Okay, let's look at the other triangle. Let's look at this one. I want to do the same thing again. I want to come up with a formula for the height. This time, using the three things that I can see. All right, so Casey, what is the name of side H from the perspective of alpha? Yeah, it's opposite again. And Ethan, side B, that's hypotenuse. So Francesca, what trig function are we going to use again? Why? Jack?
Sine?
Yeah, why?
Oh, because we have the opposite and the hypotenuse.
Yep. It's the opposite and the hypotenuse again. So let's set up our equation for sine again. So sine alpha equals, and Tyler, what's going to go on the other side?
That would be the opposite over adjacent. I mean hypotenuse, right?
Mm-hmm. And can you just tell me what those are in this one?
H over B.
H over B. All right, so now I got my equation set up, and I want to get H by itself. So Zach, how would I get H by itself there?
Multiply by B.
Yep, multiply both sides again by B. It's exactly the same thing we basically just did. And now, you get a formula for the height again, and I'm going to call that box 2. Now, let's look at the whole thing. What do you know about box 1 and box 2? I'm thinking, like, how would box 1 compare to box 2 if you had numbers to plug in? Yep.
Well, they both have the sine function in them.
Okay, yep, they both have the sine function. Yep.
They're both equal to h.
They're both equal to h, so what does that mean? Both boxes are equal to h. So that means
They're equal to each other.
they're equal to each other. Box 1 and box 2 are exactly the same thing. So now, let's write that down. And that is pretty much getting us where we need to be. So we have A sine beta, that's box 1, equals B sine alpha. Now, when we normally write this law, they usually put the A over with the alpha, and they put the B over with the beta. So how could you move the A so it's over with alpha? Yeah,
Divide each side by A.
you divide each side by A. And how could you move the B so it's over with beta? Yeah, Matt?
What's the question?
How would you move the B over to the other side?
Divide it.
And that pretty much is the law of sines. Okay, there's one more fraction we'll write down. We didn't prove where that one came from, but it follows the same pattern as the first two. Right, so right now we have sine of beta over B equals sine alpha over A. Usually they put it in alphabetical order. So let's do it that way. Sine alpha over A, just going to write that part first. Sine beta over B. And does anyone have a guess what the third fraction would be based on the pattern of the first two? Yeah.
I don't know. I forget what it's called. It's sine, and then like the Greek letter for the C. And
Yeah, gamma
Gamma over C.
over C. So we didn't prove that last part. We could prove that very easily, just like we did the first two, by drawing, instead of drawing a line from the top straight down, we could draw a line from the other side, and we could do it that way. But that is the law of sines. So sine of alpha over A equals sine beta over B, which equals sine gamma over C. Now, when I talk about the law of sines, I usually refer to it as having three parts. You never have to use all three parts at the same time. You either use the first two to figure something out, the last two, or you can use the first one and set it equal to the last one. So what you're doing when you do law of sines is you're setting up a proportion. You have a fraction on one side and a fraction on the other and an equal sign between them. So you can still use the fact that all your angles add up to 180. That's definitely true. But Pythagorean Theorem is out the window, because Pythagorean Theorem only applies if your triangle has a 90-degree angle. Well, every problem that we do as an example in class today is not going to have a 90-degree angle. Okay, so that's why we have to use law of sines instead of Pythagorean Theorem. All right, any question on what the formula is before we try 3 examples? We'll do one of each type. All right. So let's look at this one. The first thing you should always try to figure out, and again, it doesn't really apply too much in this section because you don't know the other law yet, but you should figure out if this is a law of sines or law of cosines problem. I may ask you on the test, is this problem law of sines or law of cosines? I could give you a law of cosines problem. I wouldn't expect you to be able to solve it yet because I haven't taught you that. But all you'd have to do is say this is law of cosines. We haven't solved that yet. Something like that. So what's the easiest way to see if this is law of sines or law of cosines? What do you think you want to do? Yeah. Okay, how would you confirm that? How can we make it, like we have the information here, but how can we represent this information a little differently so we can see its law of sines?
Setting up a triangle.
Yeah, let's set up a triangle, draw it, and see which one of the three types it is. So here's a triangle. Let's put A across from alpha, B across from beta, and C across from gamma. Except beta you can fill in because we know it. All right. So using the three letters, can somebody tell me what type of triangle that is?
ASA?
So to be ASA, that means you have to know two angles and the side that's between them. What side is between the two angles that we know?
C.
Yeah, do we know C? No. So this is an ASA then. Which type is this one? Yeah.
SA.
Yeah. It's AAS or SAA, you can say it either way. But the point is, you know two angles, and you know a side that is not between them. If you look that up in the notes, that is definitely law of sines. That's how you do it. Okay, so let's make a table. Put your three sides in one column. Put your three angles in the other. And fill in everything you know. All right, so A is 4, alpha is 20, and beta is 60. What can we find here pretty quick? You don't even really need law of sines or anything fancy to do this first thing. Yep.
So you can find gamma.
Yeah, we can get gamma. What is gamma going to be? Sarah? Yeah, it's going to be 100 degrees because all the angles have to add up to 180. Let's put boxes around all the things we're going to find. And that's it. So we got gamma. Now we can find either B or C next. What did I say about using something, we've done this in the past, using something you've calculated to calculate something else? Zach? Yeah, we shouldn't do that. Why not? Yep. Zach.
They can't be totally accurate, well, it might not be.
All right, and what happens if it's not right?
Then all the solutions that you used are wrong.
Right, everything you used that to solve for is going to come out wrong. And when you're doing a right triangle, you can avoid using things you've calculated to calculate other things. When you're doing the kind of problems we're solving this week, you can't. You're going to have to use things that you've calculated to calculate other things. That means if you make a mistake on something, it will mess up something else. In this problem, if you get gamma wrong, it will mess up C as well. You could still get B right. Okay, B has nothing to do with gamma. Each row, everything kind of affects what's in its own row. All right. So if gamma is wrong, it's going to affect C. But beta was given, so we're fine. We could still get B. So it doesn't matter which one you do first. Let's do C first. Get that one out of the way. Every law of sines problem starts out just like this. Two fractions, sine in the top of each one of them. The first thing you want to do is look at your table and pick a row that has everything in it. No unknown numbers. So Casey, what row here has everything in it? Yep, row A. So we're definitely going to use this row. Let's go back to the formula and see how we plug that in. So find the part of the formula that has A in it, and we are going to do that first. Sine of alpha divided by A. All right, so sine of 20 divided by 4. And now we're solving for C. So we're going to use this row. So go back to the formula and see what the formula looks like that has C in it. Sine gamma divided by C. Okay, that's going to go on the other side. So sine of 100 divided by C. Now this is a proportion. In Algebra 1, you probably see it more like this. But either way, you have numbers in 3 spots and you got a variable in the 4th. Does anyone remember the name of the technique you use to solve a proportion? Has to do with something on the diagonals. Yeah?
Butterfly?
Okay, what do you mean? What's that?
I just meant
Butterflies. Yeah.
Cross multiplication.
Okay, yeah, I've heard of that. Cross multiplication. Is that the same thing? Is that what you meant?
yeah, sure.
Okay. So you cross multiply. So you multiply the diagonals and you set them equal. So in this case, let's get rid of that. 4 times 100 equals C sine 20. And now the last step is to get C by itself. So Abigail, how would we get C by itself there?
So divide by sine 20.
Divide by the sine of 20. That's gone. And there's your answer. Okay, we're going to type that in. You have to round it off. That's fine. You just round it. And generally, we'll probably do 2 or 3 decimal places. Let's do 3 on that. All the problems in this section are going to be in degrees. Okay, so make sure for these kinds of problems, you set your calculator in degrees. We're going to go 4 sine 100. You do have to close the parenthesis. If you don't, it's wrong. Divided by sine 20. So when you type it in, that is what you should get. 11.518. If you tried it and you got that, you did it right. If you didn't, then you typed it in wrong. Okay, 11.518. And now we've got 5 out of 6 of the things. So now there's only one thing left. Well, I've got 2 of the sides. Can I just do Pythagorean Theorem to finish it up and get B? What do you think, Tyler?
No.
No. That's not a right triangle. If you try to do Pythagorean Theorem, you're assuming you have a 90 and you don't. So it's not going to come out right. So we're going to find B the same way we found C. Set it up again. So remember, pick a row that has everything in it, and pick a row that has the thing you're looking for. You have 2 rows with everything in them. So technically you have a choice. Which row should I use as my row that has everything in it? Sarah?
A.
Yeah, use A because it was given. There's no decimals. We know it's right. I'm not saying you can't use C, but now if you got C wrong, now you're using it to find B, and B's wrong. So don't use it. So we're going to do sine of 20 over 4 equals. And can someone tell me what's going to go on the other side to find B? Sarah?
Sine of 60 over B.
Yep, sine 60 over B. Now, once you've done a lot of these cross-multiply problems, you kind of start to see the pattern. If you can jump right to the final answer here, that's fine. What's going to end up happening is it's going to be this times that divided by sine 20. That's always the pattern. So it's the product of the 2 numbers on the diagonal that don't have a variable divided by the number that's on the diagonal with the variable. If you can't remember that, then that's okay. Just do it out like we did last time every time. All right, and now we've got 4 sine 60 divided by sine 20, and that gives me an answer of 10.128. And that's E. Okay, you should always check when you do it that the biggest side lines up with the biggest angle, and the smallest side should be in the row with the smallest angle. If that didn't happen, something is definitely wrong. Right, but that's a law of science problem. That's how you do it. Any question on that? All right, so that was the angle side. Let's look at this type, which this time they already give you the diagram. Okay, so I want you to look at that type and see if you can tell me, using 3 letters, what type of triangle it is. Yep, Jake?
ASI.
Yep, that's ASA. If you look back in the notes, ASA, that is one of the types we use law of science for. All right, so let's go through and see what we know and what we need to find. So Casey, do I know A? No. Francesca, do I know B? Well, you know what? You tell me what we know. Tell me, what's this 40?
Isn't that the C?
Well, it's a Greek
Would that
letter.
be the D?
This is going to be a Greek letter. What Greek letter would that one be?
Beta?
Beta. So that one's going to go here. And what about that one?
Nothing beta?
You say it again. Which one?
That's the, what is that one? The one you said?
Which one are you pointing to?
General.
The gamma, yeah.
Gamma?
Yeah.
No, gamma is unknown. We don't know gamma. So we're going to put a box around that. So we need to figure out gamma. That's alpha.
Alpha.
So A is always across from alpha, and there's your three pieces of information. Well, except for this one, 4. We didn't put that one yet. What's the 4? Okay. Yep. That has to be C because A and B are labeled already, and they don't have numbers, so 4 must be the C. Or C must be 4. All right. Now, when you look at your table, in order to use law of signs, you have to have a row with everything in it. Do we have a row right now that has everything in it? No. So now the next question, can we find something and then we will have a row with everything in it? Tyler, what can we find?
Can find gamma.
We can find gamma, yeah. So Bailey, if I find gamma, what is that going to come out to? Well, what do alpha and beta add up to?
85,
And what do you have to minus that from?
1, 2,
Mm-hmm.
is it 95?
95. Now, it's very important you get that one right. It's even more important you get it right this time than it was in the last one. Why do you think it's really important you get gamma right? Yeah.
So you're going to be using it to find the rest of your answers.
You're going to use it to find everything. Okay, you have to use the row that's complete, and that's your complete row. You have to create that. So if you get gamma wrong, it will automatically mess everything up in this problem. All right? Won't even be able to get partial. Right? Everything will just be wrong. All right, so now finding A and B is just like what we did before. Zach, which one do you want to find first?
A.
A. Okay, so we're going to find A. And Sarah, can you tell me how to set up my equation to find A?
Sine of 45 over A.
Yep, so she put the unknown information on the left. That's fine. You can put it on either side. And what goes on the right?
Sine of 95 over 4.
Sine 95 over 4. And now we're going to cross multiply. And Jake, can you tell me what A will equal just in terms of like this times this divided by that?
4 times sine of 45
Yep.
over sine of 95.
Perfect. All right. So type that in and see what you get. 4 sine 45 divided by sine 95. If you typed it in correctly, or if you typed it in the right way, you should get 2.839. And that's A. All right, how about Pythagorean Theorem to finish this off and get B? Can we do it? Couple people, Jake, how come?
It's not a 90-degree triangle.
We don't have a 90-degree angle. If you use Pythagorean Theorem for B, you'll be close, because gamma is close to 90, but close is still wrong. So don't use Pythagorean Theorem. All right, let's put it right over here. Find B. And Bailey, can you set up my proportion to get B?
Sine 40 over B.
Okay, so you got sine 40 over b. And Matt, can you do the other side for me? Sorry, say it again.
2.839.
Well, it's going to be sine of something, yeah.
2.839.
No, that's not an angle, that's a side.
Oh, angle. Sorry. 45.
45, yep.
And then 4.
Well, you don't want to mix and put these two things on the same fraction because they're not in the same row. You have to keep the rows together in your proportion.
So 2.839.
2.839. Okay, so now we'll cross multiply. And Abigail, can you tell me what b will equal? Yep. So let me write that first. 2.839 sine 40. Yep, go ahead. Over sine 45. All right. And let's see what we get with that. So 2.839 sine 40 divided by sine 45. Okay, we get 2.581. And that's how you solve an angle side angle. Any question on that? All right, so the last type. That's the worst one, okay, because there's something you have to look at that could happen. Sometimes it does, sometimes it doesn't. If it doesn't, great, then it's just like this. But if it does happen, then it's a little annoying. So when we solved this problem, there were three things we had to find: A, B, and gamma. When we solved for A, we got one answer, 2.839. When we solved for B, we got one answer. And when we solved for gamma, we got one answer. In the first problem we did, B had exactly one answer. So did C, and so did gamma. When you're solving a side-side angle problem, which is what this one is. I'm going to do this problem in a second. I'm just putting the information there now, but we're going to write it in the table nice and neat. You have to find three things here: C, beta, gamma. When you solve for those, it's possible that C, beta, and gamma each have one answer, which would mean it's just like the first two problems we did. Or what could happen is each one of those has two answers. Two answers for C, two answers for beta, two answers for gamma. So then that's six things we end up finding. Or, kind of the opposite of that, is you try to start solving the problem and you realize you can't do it. It's a no solution. If it's a no solution, that means C has no solution, gamma has no solution, and beta has no solution. They all have no solution. Side-side angle is the only case where that can happen. Out of all 5 cases we're going to study, 3 today and then 2 in a couple lessons, that's the only one that this can happen. All right, so that's important to check. When you start solving this problem, you want to do it just like I'm about to show you. Okay, and I'll show you how you see if there's a second answer or if it's a no answer. If it's a one answer, you should already know how to do it. That's what we just did. All right, so here's my table. I just copied the information from above. Now, the other thing about side-side angle is you have no choices about the order that you solve for the 3 things you don't know. You have to find them in a certain order. What do you think you have to find first there? Yep?
Beta.
You have to do beta first. If you have a row that's completely empty, you might as well just cover it. It's useless. An empty row tells you nothing. To use law of signs, you have to have a full row and a partial row. You cannot use an empty row, ever. So that's what we're going to do first. Once you figure out beta, then you'll have 2 out of 3 of the angles. Well, once you know 2 angles, you can add up and subtract from 180. And that'll give you the third one. So you have to get this angle first, this angle second, and then once you get gamma, you finally have a piece of information in the last row. That makes it a partial row. Now you can figure out the other part, which is C. So you have to go in that order. Okay, so let's start with beta. So we're going to set up law of signs just like we always do. Let's do sine 40 divided by 3 equals sine beta divided by 2. Now, already that looks different than the last 2 problems we did. Anybody tell me what's different about it? Yeah?
There's no longer a variable in the
There's what?
There's
In
no
the
longer
where?
In the denominator.
Yeah, we don't have a variable in the denominator. The variable is in the trig function. So now you're going to have to do something to get rid of the trig function. Well, before we can even get rid of the trig function, we've got to get rid of this number 2. So how can we, let's put the 2 on the other side. Jack, how could I do that?
Multiply by sin 40.
If you multiply by sine 40, that would just give you sine 40 squared there, and then you have sine 40 here like that. So that, multiplying by sine 40, that would end up making it a little more complicated. Anyone have another guess how we can get sine beta by itself? Yep.
Multiply by 2.
Multiply by 2. Times 2. Times 2. So now we have 2 sine 40 divided by 3 equals the sine of beta. Now I want beta. I don't want sine. So what do we do to get rid of that sine, Sarah? Take the inverse sine. Now, just to look at this real quick, sine of 40 is in what? 40 is in what quadrant? Sarah? It's in quadrant 1. What trig function? Well, does sine come out positive in quadrant 1? I think Casey. Would you remember which trig functions come out positive in quadrant 1? What letter we use there? A, right? They all come out positive. So the sine of 40 is going to be positive. Times 2 is still positive. Divided by 3 is still positive. So this is a positive number. That's important to remember. That is always going to be a positive number. Always. All right? So we take the inverse sine of each side. And now we're going to type that in. Well, let's see what happens. Inverse sine of 2 sine 40 divided by 3. Well, this isn't a no solution problem. If it was a no solution, then something like this would have just happened. It would have said error. That didn't happen. And I lost my answer. It was 25.374. Yeah. So So I got 25.374. That is definitely one answer to this problem. So we know we have one answer. Let's write it down. But put it in the top of the box. Just in case there's a second answer, we have a little room in the bottom we can put it. Now remember, you're looking for where sine was originally equal to a positive number. Because if I just hit undo and bring it back to what it was, sine equals a positive number. What other quadrant is sine positive in? Yeah? 2. How do you get an answer in quadrant 2 using the one you already have? Yep.
180 minus the reference angle.
180 minus the reference angle, 25.374. If there is a second answer to this problem, that's it right there. If it works. What angle was I given to start this problem? Yeah?
40.
40. If there's a second answer, it has to be 154.626. Just even say 154. Could you fit a 154-degree angle and the one that was given in the same triangle? Yeah. No. If you try to put those two in the same triangle, it adds up to 194. That's too big. If it's too big, we can forget about it, and we can finish this problem just like any other problem. So just to kind of recap what we did. You find that first angle. You subtract it from 180. That's the second answer if it works. To tell if it works, add it to 40 and see if it fits in the triangle. If it adds up to more than 180, it doesn't fit. Like if this second answer was 110 and I add it to 40, well then I get 150. I'd say, yeah, it works. But this time it's too big. So we can cross it out. We can forget it ever happened. We don't need it. Okay, all we need is the 25.374. Now, how can I get gamma? That's the second thing on my list of things to do in this problem. Okay.
Just subtract the sum of alpha and beta from 180.
Yeah, so these add up to 65. So just subtract that from 180, and there's your answer for gamma. So 180 minus 65,374, that's 114.626. Okay, and the last thing, to get C now, do it just like we did the first two. Pick a row that has everything in it. Use that. I would pick row A because we know it's right. So let's do sine 40 over 3. And what's going to go on the other side to finish it up and solve for C? Sarah?
Sine of 114.626 over C.
Yep. So when you cross multiply and get C by itself, you are going to have 3 sine 114.626. And you're going to divide that by sine 40. So you should get an answer from C of 4.243. 4.243. Alright, so this didn't actually end up being bad because it didn't get into 2 solutions. In terms of the test, I would probably focus on the kind of situation that we just covered here. Probably not going to test you on the type of situation that could come up that we haven't covered yet. Okay. All right. So that is the homework for tonight. So it's 5 through 8, 10, and 16. So I think it's 6 questions in the book. And then let's just call this one question A and question B. I just made those 2 up. And let me put also a list of topics that are on the test. So there's a list of topics that are on the test, starting with 7.5 and going through 8.1. This is what we did today. Solving trig equations, that was 7.6. The sum and difference and evaluating multiples of 15, that was 7.5. And yeah, that's everything that's on there. Pythagorean identities, that's part of solving trig equations.